Algebra 2, Section 3.2, solving multi-step equations. Really just have 5 examples to work through here. It's really just the continuation of the previous lesson, so let's get into it. Basically, what I said in the last video still stands. Ask yourself what's happening to the variable and then undo things in reverse order. But sometimes things need to be simplified or distributed or any number of things before we can do what that says. Okay, so for example, here you have like terms. Before we can ask ourselves what's happening to the variable singular, we're going to have to combine like terms because right now the variable is appearing twice. So 3a plus a is 4a. The plus 6 is still plus 6, and the 90 is still 90. And really then this just becomes just like a problem from section 3.1. Subtract 6 from both sides. By the way, if you need to show minus 6, that's perfectly fine. I show it sometimes and I don't sometimes. That's not the required work though. So if you leave this out, as I'm doing on this example, that's no problem. What I'm showing is the required work. You should have a line that says 4a plus 6. Now, we have 4a, we have subtracted 6 from both sides. That would leave us with 84. Now you're going to divide. If you want to show divide by 4, that's perfectly fine, but not required. You're dividing both sides by 4. That would leave you with a, and 84 divided by 4 would be 21. Your solution is 21. Okay? And by the way, please work down the page. I should have mentioned that in the last video. You must work down. Do not work across on lined paper. I will address it with you if you're working across. Please work down. The equal signs should all line up. I'm not opposed to, you want to save paper on your homework. I'm not opposed to you making another column, right? So you do 1, 2, 3, 4, and then you get up here and you do 5, 6, 7, 8. It really kind of depends on how you space things out on your paper. I'm not opposed to that at all, but I am opposed to you working a singular problem across on one line. That's not going to work. And the longer you stick to that, the worse it gets for you. So you gotta stop yourself from doing that now if that's you. By the way, 21 times 3, if I plug that in right here, if I plug 21 in for A, 21 times 3 is 63, plus 6 would be 69, and then if this is 21 also, 69 plus 21 is in fact 90. It checks. Here's a real life example. You need to build a rectangular pen in your backyard for your dog. One side of the pen will be against the house. 2 sides of the pen have a length of X feet and the width will be 25 feet. What is the greatest length the pen can be if you have 63 feet of fencing? Okay, so let's draw a quick picture. Here's the house. Here's the pen. I don't know if I'm drawing it to scale or not. You won't know because while they say length, and I always think of length as being longer than width, and they're saying the width is 25, it may turn out to be shorter. So anyway, they said that 2 sides are X, so that would be like this, and then the one side that we do know is going to be 25, because that's how you're going to go out and do your dog pen. By the way, it did say you. So that's what you want. I don't know how wide this dog pen is going to be, but it's got to have a length of 25. Anyway, X plus 25, your 3 sides that aren't against the house, equals 63. We want to use the maximum of the fencing, so it's not an inequality. It's equal to 63. And they do that just so you can see that, again, you're going to combine like terms. This would be 2x plus 25 equals 63. Quickly subtracting 25 from both sides, you'd have 38. And dividing by 2, x would be equal to 19. Okay, so even from the beginning, as I said, they're calling x the length, but in fact, I think of length as longer than width. The length would really be the 25 to me, and the width would be 19. Anyway, x came out to 19. You have 19, 25, and 19. You could check that real quick, make sure they do add up to 63. That would be like plugging 19 into these 2 variables right here, right? 19 feet. Moving on. In this situation, we want to distribute first. Actually, I'm going to give you 2 ways to do this. Most people would look at this and go, oh, get rid of the parentheses by distributing. Okay, perfectly fine. 2x, and then you're distributing like this, right? So this would be minus 6 equals 8. be careful when you're distributing. I know it's simple. I'll tell you, I've probably 100 times in my career just carelessly forgot to distribute to the second term there. In fact, I did it last week when I was making a key. I think it was in Algebra 2 that I made that mistake, but so easy to make even for someone who has a degree in math. So just it's not about your ability in math, it's about carelessness. Be careful. And add 6 to both sides. Now you see how this is just like a problem from 3-1. You're just adding 6 to both sides. That'd be 14. And dividing by 2, x is equal to 7. Okay. Now I would like to suggest to you that there would be a different way to do this. Let me rewrite the problem. And I do like this way a little bit better. I think it opens your mind a little bit. And that would be if you, instead of distributing, if you would divide both sides by 2. In fact, this really could fit into the category of a 3-1 problem if you do it this way, because it's just 2 steps to the answer if you do it this way. Yes, you absolutely can divide by 2. This is 2 times the quantity x minus 3. It's just a multiplication of 2 quantities. So when you divide by 2, it's like the 2's cancel here. It's not like the 2's cancel. They cancel. And that would leave you with just x minus 3 on the left. Don't even need the parentheses now because that's all that's left. You've gotten rid of the multiplier, the 2. 8 divided by 2 is 4. If you add 3 to both sides, you get x equals 7. And I don't mean to continue to emphasize the check, so you can check it on your own if you want. I'm going to move on to the next problem. X equals 7. I'm not trying to say you have to do it this way. I am trying to maybe just implore you to realize that you can do this step. If you like the distributing, that's okay too. All right, now fractions. As with the last example, there really would be 2 ways to do this problem as well. I'm not going to do both ways on this one. I definitely have a way that I want to steer you on this one. The way that I'm not going to do it would be the way of getting a common denominator. Now, I'm not against you getting a common denominator. You're kind of on your own, though, as far as the method, because I'm not going to show that right here. But yes, you absolutely could get a common denominator. I believe the better way to do this is to do what's called multiplying through to clear the fractions. It's called multiplying through because you're going to multiply everything by the same number, and it's going to clear the fractions because the number that I'm picking is one that is a number that will clear both of these denominators. In fact, it is the least common multiple of the 2 denominators, 2 and 5. Okay? Now, sometimes we can come up with a number that's less than that, depending on the example. Here, it's got to be 10. Because when you multiply 10, and I just think of it like distributing, except don't forget that you're distributing to the other side as well. Whatever you do to the left side, you have to do to the right side as well. So I'm multiplying all of the terms, both left side and right side, by 10. And you see, when you multiply this fraction by 10, it's like multiplying by 10 over 1. And when we multiply fractions, you'd get 30x over 2, which reduces to just 15x. And I'm going to say a little bit more about that, but let's just finish this step here first. In here, you'd get 10x divided by 5, right? Because you multiply 10 by x, you get 10x. You multiply 1 by 5, you get 5. You have 10x over 5. That would reduce to 2x. And don't forget to multiply the other side by 10. In a way, I like to show it by distributing, but in a way, it's really just you're multiplying the left side by 10 and then the right side by 10 like this. Okay? Think of it either way. That's going to be 170. Now, one other thing before we move to the answer. It's even better still if you would, instead of multiply first and then divide, to divide first. You're going to bring the numbers down and it'll be smaller for you if you divide first. 10 divided by 2 is 5, and then 5 times 3x is 15x. I say that again. 10 divided by 2 is 5, and then multiply it by 3, and you'll get your 15x. Go to the second fraction. 10 divided by 5 is 2. 2 times x is this. Okay? And then you have your 170. All right, combine like terms. You got 17x equals 170, and then divide by 17. That's easy. That would give you just x equals 10. Now, it's a total coincidence that the answer is 10 and the number that we multiplied through by was 10. That's completely a coincidence. That's not usually going to happen. By the way, 3 times 10 over 2 plus 10 over 5. Wondering if that's equal to 17. This would be 30 over 2, which is 15. 10 over 5, which is 2. Yes, that does equal 17. It checks. And like I said in a previous video, I don't require you to write down a check. I just felt like it was maybe beneficial on that problem. Last one. You see, by clearing fractions, multiplying through to clear fractions on the last problem really sets up this problem nicely as well. Think about what you could do so that you didn't have to deal with decimal here. Now, when I say that, I don't mean to say, hey, you know, let's do whatever we can in our power to get away from the decimal. You certainly could subtract 18.65 from both sides and divide both sides by 0.6, or we could also say multiply by the reciprocal of 0.6, which would be 5/3. But a convenient thing to do would be to take a step and multiply by 100. Multiply this by 100, multiply this by 100, and multiply this by 100. Because that will just move the decimal so that this will become 1,865, this will become 2,285, this will become 60. 60a plus 1865 equals 2285. Okay? Sometimes it's just easier to work out of the decimal, not in decimal. Now you're going to subtract 1865 from both sides. I just did that on my calculator because I don't want to make a mistake. That's 420. And then you're going to divide both sides by 60, and a is equal to 7. And again, I spent enough time on checking, but if you'd like to check it by plugging 7 back in and making sure the left side equals the right side, you could do that. Probably might want to use a calculator on that one. Anyway, thanks for tuning in.